Hello everyone. There have been some student emails regarding doubts pertaining to this particular question, that is estimating the OC and SC test readings. What I thought, I will solve this question completely taking one sample problem so that it will be convenient for all of you. In fact, everybody should see this video because I'm right away solving directly the question from the exam. And one small thing, so this particular set of questions, it has four, right? So it starts with question number two. So two, three, 4 and 5 and 6. So this question number 6, actually there is a error in the choices. There is no correct choice in this one. So sixth question, it is actually not a correct question, but up to 5 questions everything is correct. So let us solve and see what happens. Okay. So let's quickly begin by making a diagram. So here 4.7 kVA, 470 by 230 volt, 50 hertz transformer. Okay, so what I will do, I will make a drawing of the question. So this is the question is about estimating OC and SC test results. So here I am drawing the transformer. So let's look at the uh, parameters. So 4.7 kVA, 470 by 230. Okay. So 4.7 kVA and 470 divided by 230 volts, and it's a 50 hertz transformer. So now obviously this is the primary side and this is the secondary side, and it happens to be a step down transformer. That means the primary side is high voltage and the secondary side is low voltage, because the voltage is stepping down from 470 to 230. Now there is a twist in this question. So from what the video, so here if you see, so here the some video is linked right at the below hint. So there the it is actually step up transform, but here I have given step down transform, so that is the twist in the question. Anyway, let's complete the diagram first. So here I have this equivalent resistance 262. So all these things, all parameters are referred to primary side. So that means now what I have to do, in the primary side I will make the circuit parameters. So this is the R naught, this is my X naught, and this is R01, and this is JX01. So this is equivalent resistance referred to primary, equivalent reactance referred to primary, and this is the iron loss component, and this is the magnetizing component. Anyway, so let's go back. So the values 262344. Okay, so 262. Let me give change the color for the values. So 0.262, not this one, plus J 344. And coming to R naught value 704 and 402. So 7, I have a problem with the connectivity. Okay, so uh, got reconnected. So 704 and 402. So I got the values written here. So now let's conduct the OC and SC test. Okay, so let's look at the first question. If a student correctly performs open circuit test and short circuit test on transformer, then calculate what meter readings based on the above data following the following six questions. Okay. So now, as a general practice and from practical convenience point of view, which side of the transformer should be meters to be connected for OC test? And this I have already mentioned. So the answer here is D, the LV side and HV side. Okay. So let me write down that one. So OC test meters on LV side. SC test meters on HV side. So that means what in the OC test, open circuit test, meters will be on the LV side and the HV side will be open circuited. In the SC test, meters will be on the HV side and the LV side will be short circuited. Okay. Anyway, so here primary secondary terminology we need not worry about. You only worry about which side is the HV and which side is the LV, and based on that you have to do the test. So now in this case, if I want to perform OC test on this transformer, I need to keep the meters on the LV side. That means the supply is also on the LV side. So, but then these parameters R naught and X naught are on the HV side. So this R naught and X naught will be transferred to the other side for the OC test. And as far as OC test is concerned, this R naught one and X naught one will not be considered because anyway the circuit will be open circuited. So you need not worry about these two. So now let us transfer R naught and X naught to the LV side. Yes, so that is for the OC test. Okay, so let me write it here itself. So OC test. Now, what is the K? K is the voltage ratio V2 by V1. This is just a standard terminology. So that is 230 divided by 470. Then uh, this 704, so R naught on the secondary side. Okay, let's ROS, let me call it. So that is 704 multiplied by K square. Okay, so I'll get some value here. Similarly, X naught to the secondary side will be 402 multiplied by K square. Again, I will get some value here. So let's calculate these two values. First, let's calculate the K. I'm opening a calculator. So 230 by 470. So 230 divided by 470. So this value is 0.4893. Okay, I don't know whether it's possible to store it in a variable and reuse it. Maybe. So anyway, answer is there. So let's at least for the first time I will use that. 489 4894 I will round off. Okay, so the K is 0.4894. So now 704 into K square. Okay, so let us do that. So I'll square this. So into itself. So this is K square 2395 and multiplied by 704. So this is 168.59, or I'll make it 168.6. So similarly, this one. Uh, so I will divide it by 704 again. So this will give me back k square. So this is k square. So multiplied by 402. 402. So 92.27. 96.27. Sorry. So this is 96.27. So now let me make a circuit just for understanding. So on the primary side, I am having these values R not 1 and X not 1. And this is my HV. So this is open. And on the secondary side, I have these two values. So this is the secondary side. So 470 by 230. That means here I will apply 230 volts AC. Okay. So here this value we just calculated, that is 168.6 and 96.27. So I think which is which we need to be careful. So here I need to give inductor symbol. So now accordingly, the current flowing in this branch is called IW, working component of the current, and current flowing in this branch is called I mu. Okay, so the magnetizing component. So these two quantities let us calculate. So what is IW? So that will be 230 divided by 168.6, and I mu will be, so this is actually J. I'm just omitting J because I will address it later. 96.27. So let us calculate these two currents. 230 by 168.6. Uh, since it is a simple calculation, let me not change the window. I'll just do it on my phone and then calculate. So I'm getting 1.364 amperes. Similarly, for the second one, 230 divided by 96.27. So I'm getting 2.389 amperes. So this is working component and this is magnetizing component. These two are 90 degrees with each other. So to get the I naught, so I can simply square these two and then take the square root of that. So it is like this one. So this is IW and this is I mu. So I want I naught. So IW square plus I mu square under root. Okay, so that's what we need to do. So let me quickly calculate that. Again, I'm doing it directly on my phone itself. 1.364 square and square root of it. So here answer I'm getting 2.751 amperes. Now what is the input power? Okay, so that also let us calculate. That way complete solution will be there. So P open circuit, power of the open circuit. So simply I can take this IW and multiply with 230. That itself will be the input. So IW multiplied by 230. Okay, so because that much current is, see here there is no power loss. The power loss only here. Or I can also do IW square into 168. That is also same. So anyway, so let's look at this. So 1.364 multiplied by 230. So that is 313.72 watts. Alternately, POC can also be calculated by IW square into R R naught S secondary side, whatever notation I have given. So 1.36 square into 168.6. Let's just verify. So 1.364 square. So exactly I'm getting 313.6, but here 313.72. I'll go with this. So it is, so this is my answer. So now if I do, so these are three my answers. Okay. So if I'm doing open circuit test, right? So the voltmeter should read 230. So this is the voltmeter reading. This is the ammeter reading, and this is the wattmeter reading. So three readings I got from the OC test. Okay. So similarly, let us consider the short circuit test. So SC test. So we know that SC test has to be conducted by keeping meters on the HV side. Okay. So now look at this diagram. So this branches anyway, we will not worry about it now. Only I'm interested in this one, and already these values are in the high voltage side. So it is very easy. 262344. So let me draw the circuit diagram for this. So here I can neglect the magnetizing branch because it is a open circuit test, and sorry, short circuit test. And here we make the short circuit. And here we are supplying the input. So 470 volts we are supplying. Not sorry, not 470 volt. We have to supply a reduced voltage, right? So we need to supply a reduced voltage such that the current in this branch should be equal to the short circuit current. So what is the short circuit current? It is given, it is 4.7 kVA transformer. So short circuit current I1 ISC, short circuit current, is the rating of the machine, 4.7 kilovolt ampere. That means 4.7 into 1000 volt ampere divided by my voltage is 4.7, right? So 470. So it is a 470 by 230 volts. So if it is 470 volts, so here volts gets cancelled, and then this whole thing, I think it will give me 10 amperes. So the short circuit current will be 10 amperes measured on the primary side. Okay. So now the question then is, what is the voltmeter reading? Okay. So the here the voltage on this side is 0 volts because of short circuit. That's why voltage on this side also will be 0 volts. So whatever voltage drop here is equal to the short circuit voltage. So what is the voltage drop here? So voltage drop, first I need to find the impedance. Okay. So what is Z1 or Z01? So that is 0.262 square plus 0.344 square under root. Okay. So this is the magnitude of the impedance. Okay. So we can actually do the problem in complex notation, but anyway, it is not required here. So let's do this. I'll just do it on my calculator and show you. 262 square plus 344 square and square root. So I'm getting this value to be 0.4324 ohms. So that is Z01. So now impedance is there and current is there. So the V short circuit is nothing but, I'm only interested in magnitude. So 10 multiplied by 0.4324. So which gives me 4.324 volts. So now again, if I mark everything, so the voltmeter will read this one, ammeter will read this one, and the power. Okay, so there is a wattmeter. So how much power? So 10 square into 262. Okay, so that is very easy. Short circuit power is I, I short circuit square plus R not 1. So that is 10 square into 0.262. So that should be 26.2 watts. So now I have all the values. So now let's look at the questions. So this question already we answered. The choice is D. What is the input power taken from the supply during the OC test? So I remember A should be the answer. Input power during the OC test. So if I go back and go to the previous slide, so OC test input power is 313.72. So 313.8. Okay, so looks like this is the closest answer. So my answer is A for third one. Fourth one, what is the input power taken from the supply during the short circuit test? So 26.2, again, I remember this. So if I go back and then see during the short circuit test, the input power taken is 26.2. Okay, so that is the answer. What is the supply voltage applied during the short circuit test? So supply voltage applied. Okay, so during the short circuit, 4.324. So answer is A. And finally, what is the current taken from the supply during the open circuit test? So here, see, I got 1.364 and 2.389. So those were these values, 1.364 and 2.389. But these two are individually IW and IMU. Actually, what I am looking for is 2.751. Okay. So, but that option is missing in the choices. So, this question 6 is itself wrong. Okay, it is not correct. There is no correct option in this. So, what I will do in the exam, I will simply ignore this question, and uh, all the students will get. I mean, this is not even get 1 mark because it will not even counted in the exam. So the total will I'll not count in this. Yeah. So anyway, I think I will stop here in this video. I'll make one more video with two three more other questions that are being asked. But anyway, please refer to this video before answering your question. Thank you.